and maybe like for those who may not be specifically involved in material science or additive, so you want to just talk about kind of uh, kind of maybe some of the basics here, kind of what a fatigue test is, and why does it matter what the surface looks like in a fatigue test, and why would this make a difference, or what was your hunch there? So kind of maybe explain some of your thinking and along
Yeah,
those lines.
yeah, absolutely. Fatigue is something that I didn't know anything about it before starting in this field. But what I saw was all this incoming of these fatigue testing bars into our lab, and it get me curious. So automatically I have a hunch. Okay, this is really important because everybody is testing for this. What is this? Turns out that this is a simple test. There's different ways to do it. Uh, but the easier way to explain it is when you have a paper clip, a metal paper clip, and you start bending it over and over again, it get turned hot and also it's gonna break. So it's just like that. Is that forces that you're gonna start applying into a material and you keep doing repeatedly, and at some point a failure is going to occur. Most likely those failures are coming from the surface. So you have any surface defects, it's usually referred as a stress racer. That is going to start creating problems, and a crack are going to start growing from that point, and that's when you have that crack. So
So
the
if you're
problem
able
with
to
additive,
if you're able
yeah,
to improve the surface, then you can improve the
exactly.
fatigue.
The
Got it.
problem with additive that the surface was so rich that most of these surface defects, or sometimes called notch and micro notches, were hidden with the powder, and you cannot characterize it or see it at all. So when you start doing the fatigue testing and they were trying to break this, they were breaking really fast. But then when I process the components, most of the time they never break. So under the forces and the parameters that they were using for that testing, those specimens were running forever. So it was reaching that endurance limit, which is really interesting, especially for additive manufacturing, that everything was breaking so fast. So by improving the surface and removing those stress racers, that was a hunch. Okay, this might be work. But it was just I think it was a little bit of luck in there. I think I took a risk. I should have been pushing for more those specimens and achieve a better surface texture, but I didn't. So it's okay.
There you
Now I
go.
can do it. Now customer, because the problem that I have, and I've been dealing this last 10 years. Customers always come with an RA requirements, and the question is, why do you want to achieve that RA? It doesn't make sense. Additive manufacturing is going to be really difficult to reach that RA that you're looking for, and if you're looking to improve surface texture for fatigue performance, they do not translate. And I have so much data showing that, and still there is this belief that if you have a low RA, you're going to have amazing performance. And for additive manufacturing, it's not always true. So it's really tricky,
So
right?
what are you measuring then if it's not RA, or what are you looking for that you did a
Excellent
good job?
question. It is as what we believe at this point, because this is still an open question. We don't know, but what we believe and the hunch is a synergistic effect between elimination of the micro notches from the surface, uh, achieving a smooth surface, and creating a residual compression stress on the surface. So basically, you need to create this synergistic effect. And now something else that we're seeing is heaping is really important, because if you need to eliminate internal porosity. If you have internal porosity, then most likely you are not going to be able to see those improvements. So it's really complex. But there is no in machine specimens, you just measure the surface texture, and because of that specific geometry that the machine lines create, correlate perfect. You have different arrays are going to give you different performance. In additive, it doesn't work like that. It's complex. It's complex. A lot of research that needs to be done. There's a lot of research being performed right now. Is a really cool field that is being developed. And yeah, I don't know if we're gonna come with an answer in the next 10 years, but it's gonna keep me employed at least.